Welcome back to Well, That's Interesting, the Dear God, Do I Need to Do Anything About This? edition. Today is episode 228. Our sun will eject a superflare with the energy of 1 trillion nukes, and a supermassive black hole is shooting its own beam of energy right at us. My friends, I know this sounds dire, but I have great news. No matter how many billionaires buy election after election, no matter how many tiny politicians control vast portions of your life, no matter how many theological, physical, and economic wars are waged in the name of an imaginary sky daddy, in the end, nature is going to win. And even more good news. You don't have to do anything. Just sit back, relax, and wait for her unfathomable power to come to us. For example, way the fuck back, on September 1st, 1859, British astronomers Richard Carrington and Richard Hodgson recorded an observation never before witnessed by human eyes, a bright flash of light on the sun's surface. Today, we call them solar flares, but back then, it was anyone's guess. No one had any inkling that this introduction would be one of the most catastrophic solar flares ever recorded so far. Our sun is long overdue, but I'm getting ahead of myself. Let's learn a few quick facts about what's called the Carrington effect. So, sorry Hodgson, I guess there's only room for one dick in this town. My explosive business goose. 17 hours after that flash was witnessed, the solar flare, aka the coronal mass ejection, aka huge twisted ropes scientists call flux ropes, composed of plasma and threaded together by the sun's intense magnetic field, aka a shit ton of energy. It slammed into the Earth's atmosphere, creating awe and chaos. And when I say a shit ton, and when I say awe and chaos, I mean it. According to the wiki, auroras were seen around the world and in places that have not seen them since. Quote, the aurora borealis over the Rocky Mountains in the United States was so bright that the glow woke gold miners who were reported to have begun to prepare breakfast because they thought it was morning. It was also reported that people in the northeastern United States could read a newspaper by the aurora's light. The aurora was also visible from the poles to the low-altitude areas of south-central Mexico, Cuba, Hawaii, Queensland, southern Japan and China, New Zealand, and even at lower altitudes very close to the equator, such as Colombia. Again, that was from the wiki, and on one hand, that's romantic, but on the other, the geomagnetic storm that was whipped up in our atmosphere caused telegraph systems all over Europe and North America to fail, leading to a really crappy workday for some operators who, minding their own fucking business and doing their job, endured electric shocks. Some telegraph poles went up in flames or sparked. In sum, the most intense geomagnetic shitstorm recorded in modern history provided clear evidence of the connection between solar activity and magnetic disturbances here on Earth. But get this, my friends. The good news just keeps on coming. The event in 1859 was caused by a solar flare that was just 1/100th of the energy of a superflare. And if you're wondering what that is and you're reluctant to ask, don't worry, I've got you. I will explain what in the holy hell a superflare is. We will meet the international team that poured through the data of 56,450 sun-like stars to do some clickety-clack calculations to estimate when our sun is going to let one rip. Their process was impressive, and so is the amount of energy that will probably hit us in our lifetime. Then after the break, sure, superflares are jaw-dropping, but wait until you hear about blazars. Yeah, if you're a long-time listener of this show, then you know space doesn't fuck around, and that quasars, aka some supermassive black holes, are so gigantic. They superheat the material, spiraling within their accretion disk to hundreds upon thousands of degrees. And the accretion disk is basically a waiting room from hell, where all matter, all of it, circles the actual black hole like a drain. The heat here is so intense, it emits equally gigantic amounts of electromagnetic radiation and radio waves, X-rays, and some high-energy gamma rays too. Now, we can't see those, but if the quasar is close enough to Earth, we can see the light created. And my friends, sometimes that light, that brightness, overpowers that of an entire galaxy. Anyway, the black hole/quasar's immense magnetic field funnels all this energy into jets, and they kind of shoot out at either end. Or if you rather, perpendicular to the accretion disk. These jets extend beyond the black hole's host galaxy, and in some cases, thousands of light years across. And sometimes, by chance, a jet is aimed right at us. And those are called blazars. Last year, a new blazar was discovered, and wow, it's breaking all sorts of records. We will meet the team who found it. We will talk about how they found it. We will dive into why it's oh so special. And spoiler, no, it won't pose a threat to us. It's too far away. But the idea of something like this out there is ferocious, isn't it? In the meantime, hi, I'm Jill Chacha, and if this is your first time listening, welcome to the flock, my colossal business goose. To begin, I'm going to ask you to buckle every buckle and to buckle the fuck up, because I'm about to straight up tell you about superflares and how, prior to the study we're about to thrust into, how scientists recorded them. At the top of the show, it was my honor to introduce the Carrington effect, the first documented solar flare which entered the room like a bat out of hell. Now, a typical solar flare is still a massive explosion on our sun that releases a triple-decker of electromagnetic radiation, light, and high-speed particles, and it happens when energy stored in the sun's magnetic field above a dark sunspot is released. Visually, my God, this is all stunning. The magnetic field snaps apart and joins back together, creating like a helix or a flux rope, which stretches out, slingshotting that burst right towards us. In 2024, there were 54 X-class solar flares, which is the highest number since 1996. Now, what the fuck did I just say, and what is all that? I've got you. Great news. X-class flares are the most powerful type of solar flare on the old solar flare scale. Long, fantastically nerdy long calculation short, solar flares are categorized by the level of X-rays they produce. And each flare class, C, M, and X, is 10 times stronger than the previous one. And if you haven't buckled up yet, I will give you a second to do so, because the real show is about to begin. Are you ready? Okay, you're totally not, because I have to drop this on you. For context, the most powerful X-class flares can potentially release the energy comparable to billions of hydrogen bombs. You heard me. Billions of hydrogen bombs. And get this, my badass business goose, you already lived through one of these. Out of the top 50 solar flares of the year 2024, the strongest took place on October 3rd. And the sunspot below it was around 1,800 million square kilometers in size. Why even tell me that number? It's just I can't fathom these numbers. And if you're like, also, yeah, I agree. And also, how the hell are we still alive after October 3rd? If you're wondering that, well, it's thanks to our protective atmosphere. So we might want that to stick around, because these solar flares are fucking hogwash when it comes to super flares. Let's get into it. Now, prior to the eye-opening study, the new study that I'm about to reveal, scientists very much knew about super flares, but they were considered random freaks of occurrence. According to the Max Planck Institute for Solar System Research, earlier surveys by other research groups found that they pop off every 1,000 or maybe even every 10,000 years. And this conclusion came not from direct observations of stars, but from indirect evidence, right fucking here on Earth. Quote, when a particularly high flux of energetic particles from the sun reaches the Earth's atmosphere, they produce a detectable amount of radioactive atoms, such as the radioactive carbon isotope C14. These atoms are then deposited in natural archives, such as tree rings and glacial ice. Even thousands of years later, the sudden influx of high-energy solar particles can thus be deduced by measuring the amount of C14 using modern technologies, end quote, from the Max Planck Institute website. So, that was a lot, but my radioactive business goose, you heard it right. These flares are so spectacular. Their effects can be found even today in long-buried slabs of ice, or tree rings, for example. Thanks to the old C14 method, researchers were able to identify 5 extreme solar particle events, aka superflares, within the past 12,000 years, leading to a clickety-clack occurrence rate of about once per 1,500 years, give or take. In fact, the most violent superflare is believed to have occurred in the year 775 AD, over 1,200 years ago. But we could still detect the C14 from it. That is fucking crazy. Man, if that power and the remains of radioactive particles being strewn about, if that all sounds familiar and terrifying, if it sounds like, I don't know, the effects of a nuclear blast, but an unimaginable one, you are absolutely right. I want you to take the power of an X-class solar flare, the one we just talked about, the one with the power of billions of hydrogen bombs. I want you to put that in your hand, and then I want you to multiply that by 10,000. That's give or take 1 trillion nukes, like the title of the episode says. That's a superflare. So needless to say, we might want to know when one is coming. GPS satellites, global communications, fucking every country's national security and infrastructure is at stake, basically. So, for researchers at the University of Graz, Austria, the University of Oulu, Finland, the National Astronomical Observatory of Japan, the University of Colorado Boulder, and the Commissariat of the Atomic and Alternative Energies of Paris-Saclay, one more, and the University of Paris-Cité, they were like, all these researchers were like, girl, I'm winded. And maybe we should start by updating that average occurrence rate, because we have the technology, we have the telescopes and the AI to do it. And my friends, they certainly did. This A-team of cosmological eggheads joined forces where else but at the Max Planck Institute in Germany. Now, since the last superflare occurred in 770 goddamn 5 AD, there is no way we should be waiting around for signs for the next one to hit if we want to study these things. So instead, the team turned to the heavens. Quote, we can't observe the sun over thousands of years, said Professor Dr. Sami Solanki, director at the Max Planck Institute and co-author of the study on the MPI website. We can, however, monitor the behavior of thousands of stars, very similar to the sun, over a short period of time. This helps us to estimate how frequently superflares occur. End quote. My friends, this genius idea led the team to NASA's space telescope Kepler, who between 2009 and 2013 recorded the faint but oh so important fluctuations in brightness of, get this number, 56,450 sun-like stars. And not only is that a kick-ass sample size, but, quote, in their entirety, the Kepler data provided us with evidence of 220,000 years of stellar activity, said Professor Dr. Alexander Shapiro from the University of Graz on the Max Planck site. 220,000 years of activity. That is impressive. When I said impressive, I meant it. So, after all the analysis was analyzed, what did they find? Drumroll, please. Thank you in the back. Out of 56,450 observed stars, 2,527 stars released a total of 2,889 superflares, which means around 2,500 stars farted out nearly 2,900 superflares. That means, on average, one sun-like star produces a superflare approximately once per century. Not every 1,500 years, not every 10,000 years, about a century. If you're shocked, you are not alone. Quote, "We were very surprised that sun-like stars are prone to such frequent superflares," end quote, said first author Dr. Valery Vasilyev from the MPI. Okay, that's frequent. And what does it mean? Well, the sun is overdue, that's for sure. But good news. For real. For real. Beginning 2031, the European Space Agency's space probe Vigil will, quote, "help in the endeavor of forecasting solar flares. From its observation position in space, it will look at the sun from the side and notice sooner than Earthbound probes when processes that might drive dangerous space weather are brewing on our star," end quote, from Max Planck. So, Vigil, being creepy to the side, is going to help us out a little bit in 2031. Okay, fingers crossed, I guess. Until then. After the break, move the fuck over solar flares. There's an even bigger and badder form of energy ripping through the universe as we speak. Those are, of course, the jets of quasars, aka supermassive black holes whose accretion disk is spinning so goddamn fast the material in it is pulverized to such an extent it creates so much excess energy it gets caught in and funneled by the black hole's magnetic field into two opposing columns. I nailed it. On rare occasions. That beam of death is aimed at Earth. And we found one. Next. Stay tuned.
My dad works in B2B marketing. He came by my school for career day and said he was a big ROAS man. Then he told everyone how much he loved calculating his return on ad spend. My friends still laugh at me to this day.
Not everyone gets B2B, but with LinkedIn, you'll be able to reach people who do. Get a $100 credit on your next ad campaign. Go to linkedin.com/results to claim your credit. That's linkedin.com/results. Terms and conditions apply. LinkedIn, the place to be, to be.
This episode is brought to you by Progressive Insurance. Do you ever find yourself playing the budgeting game? Well, with the Name Your Price tool from Progressive, you can find options that fit your budget and potentially lower your bills. Try it at Progressive.com. Progressive Casualty Insurance Company and Affiliates. Price and coverage match limited by state law. Not available in all states.
And we're back. We are so back. And my friends, when the Earth isn't dodging solar flares or super flares from the sun, there's another tremendous form of intergalactic space fuckery to look out for. And thems are called blazars. At the top of the show and just before the break, we had ourselves a little recap on quasars and how their jets, composed of electromagnetic radiation, radio waves, X-rays, and high-energy gamma rays, can, by chance, be aimed at us. When this happens, they're called blazars, and I have genuine good news. For real. 1, fewer than 3,000 blazars have been discovered to date, which, for space is a minute amount. 2, they're all so far away there's no real impact on us. And 3, that should put a smile on your face, because as we've learned back in December of 2024, during episode 216, Black Hole Blowtorch is causing nearby stars to explode and the world's oldest cheese has been found, rubbed on mummies. Yeah, being in the neighborhood of a black hole's jet seems to make things explode. And also in that episode, we found really old cheese. Quite literally in the last place anyone looked. And expected. Anyway, blazars. They are rare and they're frightening, so when one is found, you better believe it makes headlines. And when that blazar is breaking all sorts of records, girl, you know it's going to be on this show. Let's get into it. Join me, will you, with study co-author Emmanuel Mamjian, who is an astronomer at the National Radio Astronomy Observatory in Virginia, with study lead author Eduardo Banadios, I think I nailed that, study co-author Silvia Belladita, both astronomers at the Max Planck Institute for Astronomy in Germany, and their team, who just can't quit deep space. And by deep, I mean it. These folks are actively peering into the universe just several 100 million years after the Big Bang. And to do this, you can't use an ordinary telescope. In fact, you can't just use a single ordinary telescope. One reason as to why can be found in episode 214. Have you ever wondered why tarantulas are hairy or how dark deep space really is? We spoke about why you can't see shit when floating out there in between galaxies, thanks to the redshift effect. Now, here on Earth, we've all experienced something a little similar. For example, the increased pitch of an approaching ambulance siren and the sharp decrease in pitch as the siren passes by and recedes. The sound wave feels as if it's slowing down, as though it's being pulled as it moves farther away. Well, light behaves like a wave. The longer it travels through an expanding universe, the light is pulled and stretched into the red side of the light spectrum that our eyes can't pick up on, like radio waves and X-rays, for example. After billions of years, you're going to need some special equipment to pick this stuff up. Telescopes, like the Atacama Large Millimeter Array, the Magellan telescopes, and my favorite, the European Southern Observatory's Very Large Telescope, all located in Chile. And you're going to need NASA's Chandra Observatory in Earth's orbit. It was these the team used to gather data, and boy howdy, their new study, published in the December 18th, 2024 issue of the Astrophysical Journal Letters, it dropped a doozy. My friends, the team picked up on these waves from a supermassive black hole with a jet pointed directly at Earth, a blazar, located a staggering 12.9 billion light years away, and that is just the beginning. The black hole itself has a mass of 700 million suns, and became such a behemoth a mere 800 million years after the Big Bang. And I feel insane saying these words. And of course, there's more. It is the most distant blazar ever found so far, beating the last record holder discovered in 2020, and that one was 12.8 billion light years from Earth. This one's 12.9. Now, our new record holder has been dubbed J0410-0139. Rolls off the tongue. And it's 100 million years older and farther. So, other than saying to yourself, Christ, we are just a fart in the wind, you might also be thinking, what do I do with all this information? Well, for us, our minds can just be blown. But for the hot and heavy nerds like this team and astronomers like them, it helps them tell the story of our early baby universe. Quote, imagine that you read about someone who won $100 million in a lottery. Banados told Harry Baker of LiveScience.com, given how rare such a win is, you could immediately deduce that there must have been many more people who participated in that lottery, but have not won such an exorbitant amount. Similarly, finding one quasar with a jet pointing directly towards us implies that at some time, there must have been many quasars in that period of cosmic history with jets that do not point at us. End quote. Study co-author Silvia Belladita followed up by saying, quote, where there's one, there's 100 more waiting to be found. End quote. So what could I say? More holes, everyone. More holes with things shooting out of them will help us complete the kindergarten class photo of our universe. So watch this space. No pun intended. And thank you for listening, rating, subscribing, telling your friends that the sun's trying to kill us. And if that doesn't work, supermassive black holes shooting blazars at us will try. They're going to try. They're not going to not try. Tell them about that, and an oversized thanks to the folks over at Airwave Media, the podcast network to which WTI belongs. If you love this show, and you do, you love the other podcasts in this family. And please, stay interesting.